Imagine you have just encountered a perplexing error in your code, a sudden halt to your program's execution. A wall of text appears, filled with unfamiliar paths and technical jargon, but somewhere within it lies the key to understanding what went wrong. How do you cut through the noise and find that crucial insight? Identifying relevant information in a stack trace primarily involves discerning your application's code frames from system or library code, then focusing on the exact point where an exception was raised. This approach allows you to pinpoint the origin of the problem rather than getting lost in internal framework operations. A stack trace, at its core, is a snapshot of the active subroutines in a program at a given moment in its execution, often when an error or exception occurs. Each line, or frame, represents a function call on the call stack, showing the sequence of calls that led to the current state. Understanding this chain of command is crucial because errors typically originate from your application's logic, not deeply within a well-tested framework. You want to quickly home in on the part of the program that you wrote, where your specific business logic lives. To effectively navigate a stack trace, start by locating the exception type and message at the very top or bottom, depending on the language or environment. Next, methodically scan the frames until you find the first line that references a file or module from your own project directory. This particular frame is often the most critical because it indicates the last point your application code was executing before control transferred to a system or library function that subsequently encountered an issue. Once you have identified your application's frames, examine the function names and line numbers to reconstruct the logical flow leading up to the error. Pay close attention to variable values in the relevant frames if your debugging environment allows, as these can reveal incorrect states or unexpected inputs. Mastering the skill of stack trace interpretation significantly enhances your debugging efficiency. Modern debuggers often provide features like frame filtering, allowing you to hide irrelevant system calls and focus solely on your application's stack frames. This process of effectively. In essence, by strategically filtering out the noise of internal system calls and focusing on your own application's execution path, you transform a daunting wall of text into a precise diagnostic tool. This targeted approach allows you to quickly isolate and understand the root cause of issues, leading to faster problem resolution and a more robust code base.
If this helps you fix faster, like, subscribe, and keep debugging with us.